So Wednesday in class, we talked about the imaginary unit I, which allows us to actually come up with an answer when we need to square root a negative. We know there's actually no real answer that we can come up with when we square root a negative, but I lets us at least get a representation of some kind of answer. Okay? How it works is I is by definition has a value of the square root of -1. And what that allows us to do is it allows us to square root a negative by breaking it into pieces. For example, let's say we wanted to know what the square root of -9 is. We can break that into the square root of -1 times the square root of 9, and then we can actually represent a value for both of these. The square root of -1 is I. The square root of +9 is 3. And so basically our answer for the square root of -9 would be 3i. It's almost like the I is represented by the negative value underneath there. So if you go to the next page and look at some of these examples. The first example is the square root of -25. Okay? The negative can be dealt with by bringing out an I, and then I just have the square root of 25, which is 5. And so my final answer for the square root of -25 is 5i. So the I basically represents the fact that we had to square root a negative. Even if it's not a perfect square, the first thing I do is I take care of the negative under the square root by adding an I to the problem. And then we can just simplify this either using a factor tree or your biggest perfect square. The greatest perfect square that will divide into 48 is 16. I can break that into the square root of 16 times the square root of 3. And we know that this goes to 4. And so my simplified answer is 4i times the square root of 3. Now we also worked with complex numbers this day, which is a number that involves a real portion and an imaginary portion. And if you go to the next page, we can actually simplify using these things. All right? When you have addition of two complex numbers, you are just combining like terms. I would do 8 plus 5, which gives me 13. I would do -i plus 4i, which will give me a positive 3i, and that is your answer. So we're really just combining like terms. We can do the same thing with subtraction. Just be very careful with your signing. Remember that you are subtracting everything in the second complex number. So we would do 7 minus 3, which will give us 4. But then we have -6i minus -6i, which we know is the same thing as -6i plus 6i. And those would cancel out. And so the answer for this one is just 4. Looking at another example with subtraction, if you look at this one, we have 10 minus 6, which would give you 4. You then have -7i plus 4i, which will give you minus 3i as the final answer. Now with multiplication, you absolutely can multiply using our imaginary units. This is just the distributive property. You would get 9i minus I squared. Okay. However, if you go back one page, there is a second property we need to talk about. The second property at the top of the previous page tells us that I squared technically has a value of -1. And so one thing that is different when you're working with the imaginary units as compared to just x's is if you do end up with any I squareds, you need to replace that with its actual value, which is -1. So for this problem, I actually have 9i minus -1. Using add the opposite, my final answer is 1 plus 9i. Even if you're doing the FOIL method, okay, go ahead and multiply like we normally do. You would do 4 times 3 and 4 times 2i. You would do I times 3 and I times 2i. And so here's where you're at right after you do the multiplication. Looking for things that we can simplify. 1, we do have an I squared. That can be replaced with a -1. And so basically what I have is I have 12 plus 8i plus 3i plus -2. And now when I combine like terms, I have 10 plus 11i. The last problem we did in class today was example A at the bottom. And this is just to remind you, when you are solving, you may have to introduce the square root to get x by itself. And when you introduce the square root, you have to include the plus or minus sign. So for this problem, we would start to solve for x by subtracting 11, and that will get you to x squared equals negative 8. And then when you square root, you end up with x equal to positive or negative square root of negative 8. The first thing you would want to simplify is the negative comes out and becomes an I. And then we need to check to see if the square root of 8 will simplify, and it does, down to the square root of 4 and the square root of 2. And we know that the square root of 4 is 2. And so our final answer is positive or negative 2i times the square root of 2.